Hello children, I hope you have seen your first video on the introduction of this lesson, laws of motion. Now we are moving to the second part of the lesson which explains about the relationship between force and motion. In this we are going to see about two statements given by great two scientists. They are Aristotle and Galileo. This is also a type of introduction, but it explains in a detailed concept about the relationship between these two factors, force and motion. Come, let us see the first statement, Aristotle's statement. First, he says that all the bodies on earth, in short, earthly bodies, the natural state, by nature, all the earthly bodies will have a state of rest. In other words, the state of earthly bodies, the natural state of earthly bodies is rest. All the earthly bodies will have by nature, by default, the state of all the earthly bodies is rest. Now he describes about two types of motion. First one he says about natural motion, and second one he says about violent motion. What is natural motion? A body, if it is in motion, okay, now it needs, it comes to rest without any influence of external force. Automatically, a moving body comes to rest without any external influence of force. It doesn't need any external agency to come to the rest. Now, that's why it is called as force independent motion. Okay, the natural motion is otherwise called as force independent motion. Now, next he describes about violent motion. Now, what is this is, a body needs some external influence, external factor to come to rest or it come to motion. So that type of motion, any body, if it needs an external force, that type of motion is called as force dependent motion or violent motion. Now these two concepts, can you understand children? Natural motion, violent motion. This automatically the body comes to rest. That is, it doesn't need an external force. That's why it is called as force independent. Violent motion, an external agency is required in the form of force. So they are called as force dependent. Now he says one interesting concept, dropping of bodies. What he says, when different bodies are dropped from at an height. Okay. Now he says the heavier body falls first and reaches the ground. And he says the heavier body falls faster and it comes and reaches the ground first. So that's why he says the initial concepts which led to the development of this particular concept by the next scientist called Galileo, a great scientist, a forerunner in the field of physics. He explains about these concepts. Now come, let us get into this. He says here what he said, the natural state of earthly bodies is rest. He here, along with that state of rest, he adds one another concept called uniform motion. What he says as first concept, the natural state of earthly bodies is state of rest or state of uniform motion. What is uniform motion? When a body covers, you would have learned this, anyhow I am saying it again, recall your learned concepts. When a body covers equal distances in equal intervals of time, then it is said to be in uniform motion. Example, what can we say? The hour hand of a clock, the minutes hand of a clock, in 1 hour it will move that one full circle. In next 1 hour it will move another one circle. So that can be said as a simple example for that. So what is the first point explained by Galileo? He says the natural state of the bodies is the state of rest or the state of uniform motion. A simple one concept added to this Aristotle's concept, that is uniform motion. Now what is the second point? A body continues to be in its state. Okay, whether it is state of rest or state of motion. Till when an external force is applied. When no external force is applied, it will continue to be in its state, whether it is state of rest or state of motion. What is the second point? A body continue to be in its state till an external force is acting on it. Right? Can you understand, children? Right. Next one, a very superb concept called as inertia. What is this inertia? Let us take an example. Right now, if I am walking or if I am resting on a place, right? When I want to stand up from a place, what I want to do? I have to give a force, right? Now, when I want to get up, my body will give some resistance or position to change from my state of rest to state of motion. Now, my body should give an force to move from my state of rest to state of motion. So, every body will possess an inertia, right? So, it is, in one word, we can say it as inability of a body to change its state. When a body is supposed to be changed from a state of rest to motion, it offers some resistance, or it has to change from motion to rest, then also it offers some resistance. One simple example we can give. When we are traveling in a bus, if a sudden brake is applied, what we have to do, what we will experience? We will suddenly experience one jerk, right? So the bus comes to rest immediately, but we will be in the state of motion. Suddenly we cannot change our, we will be unable to change our state of motion to state of rest. So that inability offered by any body, that resistance offered by any body to change its state, whether it is rest or motion, that is called as inertia. Now, he gives one explained concept of dropping of bodies, what we have learnt here. What I had said here, as per the Aristotle statements, when bodies of different size and mass and shape falls from height, the heavier body falls at the fastest rate. Yes. Now here he says whether, yes, of course he didn't oppose this, but he gives a statement in a different way. How? When different bodies of different shape, size or mass, when it is false, but he gives one condition, in vacuum. What is vacuum? It is absence of air, right? When no atmosphere is present, no absence of air is called as vacuum. When bodies of different sizes, different dimensions fall in vacuum from the same height, all bodies will fall uniformly with the same rate and they will simultaneously reach the ground. I suppose you would have seen this video in YouTube. There are so many videos supporting this, like feather and coin experiment. We can watch that, right? So these are all the concepts explained by Galileo. Different bodies fall at the same rate. What is the condition? In vacuum. So these are all the concepts which will explain about the relationship between force and motion. So can you take down the questions, children? Today questions will be simple but little detailed one. What is the first question? Come on, take down. Give the points explained by Aristotle on force and motion. Same question repeated here. Give the points explained by Galileo on force and motion. So in this very important inertia you have to learn, when the bodies will fall at the same rate, that you have to learn, types of motions you have to learn. So instead of learning as single point and as different short answers, you can learn as one paragraph answers. Okay children, prepare for this so that you can proceed well to the next class. Thank you children.